Okay, bismillahirrahmanirrahim. Assalamualaikum and hello guys. Okay, so in this video we are still in ungrouped data. Okay, kita masih lagi menganalisis ungrouped data. Okay, so but now we are at 6.3 measures of dispersion, which we are going to find the variance and standard deviation. Also, we are going to find and interpret the Pearson's coefficient of skewness. Okay, so we are still in ungrouped data. Okay, so untuk 6.3, you are going to find the variance and standard deviation. Okay, so let's first read the information. So it says that the deviation refers to the difference between an observed data and the data mean. So it tells us how closely the values of data set are clustered around the mean, and a larger coefficient of variation means that the data is more dispersed and less consistent. Okay, so untuk bagi awak lebih faham for this information here, saya akan bagi contoh two example, two set of data. So this is data first, data 1, and this is data 2. Okay, so let's say ini adalah archery punya board. Okay, archery punya board. So let's say for the first round, okay, for the first round saya tembak 5 kali. So this is my result. So 1, 2, 3, 4, 5. And then for the second round, saya tembak and then ada 1, 2, 3, 4, 5. Okay, so ada 5 kali tembakan kan. Okay, so for the first round we see that data saya ataupun tembakan saya rapat to each other ataupun dia tak berselerak sangat kan. So meaning that here my data is actually less dispersed ataupun kurang berterabur. Okay, less dispersed. Less dispersed sebab dia very close to each other. And if the data is less dispersed, meaning that data satu saya adalah more consistent. Okay, more consistent. Okay, so berbeza dengan data 2, awak lebih boleh tengok that tembakan saya sangat jauh to each other. Okay, sekejap sini, sekejap ujung sana, sekejap ujung sana. So meaning that here my data is more dispersed. Okay, lagi bervariasi, lagi berselerak. Okay, more dispersed, and meaning that it is also less consistent. Okay, so these are the two difference between the two set of data. Okay, so from this that, so sebagai contoh, bila awak cari the standard deviation, so let's say the first data awak dapat 0.05 and the second data awak akan dapat lebih tinggi, which is 2.32 for example. Okay, so from this result we actually can know that this set of data is more dispersed and less consistent sebab dia punya standard deviation ini lagi tinggi. So maksudnya data kita lagi banyak deviate, lagi banyak disperse. Okay, compared to this, the standard deviation is very small, meaning that our data is very consistent and it is less dispersed to each other. Okay, so that's how you understand the variance and standard deviation. Okay, so now let's go through the formula. So the formula is, for variance, this is the symbol. So the formula for ungrouped data is the summation of x squared minus the square of summation x divided by n minus 1. And then if let's say awak jumpa data yang ada frequency, so your formula gonna be the summation of fx squared minus summation of fx and then square of that divided by n minus 1. Okay, so this is the formula for variance. And for the standard deviation, it is just the square root of s squared, which is the square root of your variance. Then, for example 10, they ask us to find the mean, variance and standard deviation for data. Okay, so we have 1, 2, 3, 4, 5, 6, 7. So our number of data is equal to 7. Our n is 7. So first they ask us to find the mean. So remember that for mean, for ungrouped data, the formula is summation of x divided by the number of data. Okay, so I'm going to use the table here to insert our value. So the first one is x. Okay, so our x we have 2, 7, 10, 9, 2, 5, and 16. And we add up all together. Okay, we add up all together, we're going to get 51. Okay, so that's how we know that our mean is equal to 51 divided by 7, which is 7.29. Okay, so that is our mean. Okay, next for our standard deviation, which is, for the variance first, so we need to find the s squared. So the formula is the summation of x squared minus the square of summation of x divided by n, and then n minus 1. Okay, so we already have this data and we know the n, and we can also know this one. So we don't have the summation of x squared. So what we need to do, you have to find the x squared first. So x squared of 2 is 4, this is 49, this is 100, this is 81, this is x squared. And then 5 square is 25, 60 square is 256. So we add up all this together, so that's how you get the summation of x square, which equal to 519. Okay, so now we insert into the formulas. So 519 minus 51 square divided by 7 minus 1 is 6. So you get 24.57. That is for variance. And last one, for your standard deviation, you just have to square your variance. So square root of 24.57 will be equal to 4.96. Okay. Okay, so that's how you do number 10, example 10. Okay, so now we are at the symmetry and skewness for data distribution. Okay, so what is skewness? So skewness measures the degree of non-symmetry of the data distribution. So if the data is perfectly symmetrical, so the skewness is equal to 0. So there is one simple way to measure skewness by using the Pearson's coefficient of skewness. Okay, so we have two formula that you can use. So this is the first one. We have the mean, median, and standard deviation. And then for the second formula, we're going to need the mean, mode, and standard deviation. Okay, so how do you know which one to use? It depends on the question. Okay, so for example, the question asks you to find the mean and the median. So you just need to use the first one. Okay, and if let's say they ask us to find the mean and mode, then you use the second formula. Okay, so there are three shapes of data distribution. So the first one is we have a symmetrical distribution. Okay, so meaning that let's say we have the median over here or the Q2, so you can see that the right hand side and the left hand side of the data is very symmetric to each other. Okay, it's the same on the left and right hand side, or the left and right hand side. Okay, so for the start of data, it has actually no skewness. Okay, no skewness, or meaning that the Pearson's coefficient Sk is equal to 0. So that's how you know that our data is very symmetric and has no skewness. Okay, so and then let's say for the second case, you calculate the Sk, the Pearson's coefficient, and you get a positive value. So your data is actually positively skewed distribution. Okay, so macam mana nak ingat? Senang je. So positive is on the right kan, positif kan belah kanan kan. So how do you remember? Just remember that kalau positively skewed, data awak ekor dia lagi panjang belah kanan. Okay, kalau tengok guys tu ekor dia lagi panjang, and then belah kiri bukit, and pendek je ekor belah kiri tu. Okay, so ekor awak lagi panjang dekat belah kanan. Okay, same as box and whiskers punya plot. Okay, so you can see that whiskers awak lagi panjang dekat belah kanan, and also the box pun lebih panjang dekat belah kanan. So that's how you know it is positively skewed distribution. Okay, and then one more, the last one is let's say you find the Pearson's coefficient and then you get a negative value. So what does it mean? So it means that your data is negatively skewed. Okay, skewed distribution. Sk is negative. Okay, so opposite to the right, positively skewed. So if your data is negatively skewed, so negative is always on the left kan. So we know that ekor awak belah kiri akan lagi panjang. Same as the box and whiskers one. The whiskers on the left gonna be longer compared to the right, and then also your box gonna be longer. Okay, so but remember that walaupun dia panjang belah kanan and panjang belah kiri, doesn't mean that the data is more at this side. Okay, so actually macam mana kita nak tengok ni is ekor panjang belah sini, meaning that the data is actually kurang dekat belah sini. Okay, same as this one. Data dekat belah kiri dia kurang. Okay, so we have more data on the left hand side if it is positively skewed, and we have more data on the right if it is negatively skewed. Okay, so that's how you know the symmetry and skewness. Okay, so now we are at the last part of the video, so we are going to answer this question. So the question says, from example 9, comment on the skewness of the distribution and then find the Pearson's coefficient of the skewness. Okay, so we have done the example 9 from the lecture. Okay, so this is our box and plot. Okay, so this is our box and plots. So looking at the box and plots, we can see that the whiskers on the left hand side is longer, as well as the box, it is longer on the left hand side. So remember that we have three shape of distribution. Okay, so it is the third case actually. Okay, we can see that the whiskers and the box is longer on the left hand side, so meaning that our data is negatively skewed. Okay, so that is the comment for our box and plot. Okay, now let's find the Pearson's coefficient of skewness. Okay, so if you still remember, we have two formula that we can use. So since we already find the Q2, which is the median, so I'm going to use the first one. Okay, the first one, as our formula. So the formula for SK is 3 multiply mean minus median divided the standard deviation as D. Okay, so based on example 9, we already found the median, which is Q2. So the Q2 or the median is equal to 61. Okay. Alright, so now let's find the mean. So the mean, the formula for the mean is the summation of x divided by n. Okay, so we know that our n, for example 9, is equal to 25. Okay, so we need to find the sum of all of this. Okay, so I use the box on the right hand side. Okay, so this is our x. This is our x. Okay, the value of x. So we need to sum all of the x. So you get 1419. Okay, and then we know that our n is equal to 25. We have 25 data, so I just insert into the formula. So 1419 divided by 25 is equal to 56.76. Okay, so we already have the mean and median. So now let's find the standard deviation. So in order to find standard deviation, you first need to find the variance. Okay, because the standard deviation is the square root of variance. So the variance is equal to summation of x square minus summation of x square divided by n minus 1. Okay, so we already have the summation of x. We can find the n, we can find the n minus 1, so we don't have the summation of x square. So how do we find this? I have done for you on the right hand side. So we need to find the x square first. So you need to square each of the data to get the value on the box. Okay, and then sum all of the x square, and then you're gonna get a value, which is this is summation of x square. So you will get 84481. Okay, so this is the summation of all the x square. Okay, you sum all of this. So now we already have this summation x square. I just gonna insert into the formula. So we have 84481 minus 1419 square over 25 divided by 24. So you get 164.11. Okay, and then last one, you need to find the standard deviation. So the S is equal to square root 164.11, which gives us 12.81. Okay, and then we can find the skewness. So the skewness is 3 multiply mean. So our mean is 56.76 minus median 61 divided by standard deviation, which is 12.81. So you're gonna get negative 0.993. Okay, so when we get the negative value for the skewness, meaning that our data is negatively skewed. Okay, because we get negative value for the SK. Okay, so you can conclude that the SK also shows that the distribution is negatively skewed. Okay, so we have proof that the data is negatively skewed using the Pearson's coefficient, and also we have proof that the data is negatively skewed using the graphical method. Okay, so that's all from me.